Hello, we're Team X equals 0 and we'll be participating in the derivative championship.
My name is Miguel.
And I am Malena.
And I am Mali.
Now, I will win more points by getting the restrictions, the name, and the range. My restrictions will be -1 and 1. Why? Because I cannot have a -1 or 1 because I can divide something over 0. For my domain, I will have -1 and 1 for the same reason. So my gaps will be at -1 and 1. And for range, I will have all my real numbers points for my team by getting the symmetry of the function. First, I have my function, and then I look if it has enough symmetry, which will give me -x over -x squared minus 1. And then I have my even symmetry, which is -f to the x equal to x over x to the square plus 1. I compare it and I see that neither rows are equal to my original function. So by this we can get as a result that we didn't have any symmetry.
To get the x-intercept, we know that the function is equal to 0. So the only thing we need to do is isolate x. So it was multiplying this times this, which gives us 0. So this is our variable, x equals 0. And to get the y-intercept, we have to substitute the variable with x. With 0, sorry. So give us 0. To evaluate the vertical asymptotes, we need to first get the restriction of the denominator. So this cannot be equal to 0. That gives us x equal plus -1. So we evaluate each term in the limits. So when the limit approach x from x1, we substitute the number in the variable, which gives us 1 over 0. So with this, we know that there is no gap, but there exists a vertical asymptote at x equal 1. We do the same thing at x minus 1. We substitute and give us -1 over 0. This also means there's no gap, but there exists a vertical asymptote at x equal -1.
And I'll be giving another point to my team with the horizontal asymptote of the function. We know that this function is infinity over infinity, so we're going to calculate the limit when x approaches infinity. When we substitute with 0 or limit in this case, we know that 1 over x, or in this case infinity, is 0, and this is 1, and 1 over x that goes infinity is 0, and in this case we know that it's 0. So we know with this that our horizontal asymptote is x equals to 0.
So to get the first derivative, we need to use the equation rule, which is derivative the numerator times the denominator minus the derivative of the denominator times the numerator over the denominator to the square. This gives us x squared minus 1 minus 2x squared over x squared minus 1 to the square. We rewrite this function and give us minus x squared minus 1 over x squared minus 1 to the square.
Now we will do the first derivative test. As we know from previous steps, the derivative of our function is minus x squared minus 1 over x squared minus 1 all of this squared. For the first step for the first derivative test is to make the derivative 0 and substitute for x. So in this case, we follow the procedure. And x equals the square root of -1. And we know that this is undefined. So we have two intervals. Minus infinity going to 0 not included, union with 0 not included to infinity. So we know that the critical point is undefined, or in this case is 0, because it will never touch. So then we know that the direction of our function, because it goes from left, it goes downward, got the final answer, which was minus 2x third minus 2x third minus 2x over x squared minus 1 everything to the third power. And this is our second derivative. Well, now it's time for the second derivative test. And we do the same procedure as the first derivative test. We got this over 0, up to 0, we equal this to 0. And then we have that x equals 0. And as you may see, that is very odd. But we know that if the constant of the second derivative equals 0, but in this case it is, then we don't have enough information of the consecutive